We are learning the derivative formulas. The last one of this section here is the quotient rule. Quotient rule is used if we have two functions, f and g, both are differentiable, and we have a new function whose quotient of these two, provided g is non-zero. Okay. If we want to find the derivative of the function when f and g both, we are assuming both are differentiable. That means we can't find the derivative of f and g both. So here is the formula. You draw a big quotient, denominator square, just square, no derivative here, just the square of denominator. Derivative of the numerator, which is f, times denominator as is, minus the first function, the numerator as is, times the derivative of denominator. So this is called quotient rule, used to find the derivative of a quotient of the functions. Let's practice our first example from the notes. F of x is x by 1 plus x squared. You need to find derivative of the function. So identify, this is the denominator, this is the numerator, okay? Derivative of this function, how do you do it? Draw the big line. Square of the denominator. In the numerator, derivative of the numerator, which is x, times denominator as is, minus numerator as is times the derivative of the denominator. Let's work it out. Derivative of x is 1 times 1 plus x squared minus x. Derivative of 1 is 0 and x squared's derivative is 2x. When you multiply anything with 1, it's just that. When you multiply x with 2x, it is 2x squared divided by, these two are like terms, so 1 minus x squared divided by 1 plus x squared squared. We cannot simplify any further. This is your answer. Okay. This is how we apply quotient rule. Let's do one more example. One more time. We're going to do this using quotient rule. Quotient rule says if we have a function which is quotient of two functions, then derivative is denominator square, numerator's derivative times denominator as is minus numerator as is times derivative of the denominator. Let's write this down. We need to find the derivative of f prime, which is the quotient of these two functions. A big line. In the denominator, just square of whatever the denominator is. Derivative of numerator times denominator as is. Keep things in parentheses, otherwise you make a mistake because negative and multiplies signs change. Numerator as is times the derivative of denominator. Let's work it out. Derivative of, nothing happens to the denominator, so just write that as is. Derivative of 3, 0. Derivative of negative 2x is negative 2. Don't do anything to this. Derivative of 5x is just 5. Is negative 2. Distribute inside. Negative 10x. Negative 2 minus 5 distributes here. 5 times 3, 15. Negative, negative, positive. 5 times 2 is 10x. I see here this 10x and 10x is cancelling. Negative 17 is the numerator. Let's practice one more example. Just to remind you the rule. Derivative of denominator. Square of the denominator. Derivative of the numerator times denominator as is. Minus numerator as is times the derivative of denominator. Okay, let's write that down. We need to find f prime x. Here, the denominator is this, square of that. This is the numerator, derivative of the numerator times, don't do anything to denominator yet, minus numerator as is times the derivative of denominator. To remind you, derivative of root x can be done using the power rule, and we have remembered that the formula for that is this. Derivative of root x is 1 by 2 root x times the next thing I'm just gonna copy, minus root x. I'm just copying. Root x's derivative is 1 by 2 root x plus 1's derivative is just 0, and we need to just copy the square of the denominator here. This multiplies inside. When it multiplies, root x cancels. We will be just left with 1 by 2. This multiplies with this. We will be having 1 by 2 root x minus, here this cancels. We will just have negative 1 by 2. Oh, I see these things cancel. So we have only 1 by 2 root x divided by root x plus 1 whole square. Basically 1 by 2 root x times root x plus 1 square.